Hello, this is Walter Leite. In this video, I'll show you how to run a regression analysis in Mplus. We use this paper by Tico, Cheng, and Kim, Administrative Support and its Mediating Effect on U.S. Public School Teachers. The paper uses path analysis, but regression analysis is a special case of path analysis when there is just one outcome. So we'll run a regression analysis based on this paper. Their model is this, as you can see here. The outcome will be teacher intent to stay in the teaching profession, and in their theoretical model, they only hypothesize that teacher job satisfaction will have a direct effect, but in teacher intent to stay in teaching profession. But in the model they actually fit, which is shown here, they have 5 predictors of teacher intent to stay in teaching profession. They are teacher job satisfaction, administrative support, teacher experience, student behavior, and teacher salary satisfaction. So we will run a regression with one outcome, teacher intent to stay in teaching profession, in 5 predictors. We will use the data that they report here, this table 1, this correlation matrix, standard deviations, and the means. So the first thing I did was to put this matrix here in a text file. So this is the data. This is just a text document. The first row is the means, the second row is the standard deviations, and then we have the lower diagonal correlation matrix. Note that I don't have variable names here because Mplus does not support having variable names in actual data. You put the variable names in your code. So close this, and here I have Mplus in a new file. I'll use the Mplus language generator as a way to get started. So I clicked on Mplus, the language generator, then SCM. Even though I'm doing regression, that's a special case. Both regression and path analysis are a special case of SCM. I'll call it Tico et al. Regression. And the data type, I don't have raw data. I have the correlation matrix, means the standard deviation. So I'm using summary data. And then for data file, I will select, I'm on the folder here, data types. He's asking for a .dat, but I have a .txt data file. So I will say all files and select by data file. Tico core SD matrix. So it's selected. I click on next. The summary data types, I have correlation matrix, I have standard deviations, and I also have means. One group, the number of observations will take from the paper. So they report here 34,810 observations. 34,810 observations. We only need to declare the sample size because we're using a correlation matrix. If you're using raw data, Mplus will take the sample size from the data. Next. Now, the names of the variables. You have to put them in the same order they are in the correlation matrix, which is this order here. So I have intent, job, admin, experience, student salary. And job, admin, experience, student salary. So the 6 variables that correspond to here. Note that I shortened experience because Mplus doesn't only accept variable names with a maximum of 8 characters. Click next. Um, you can do an analysis where you have multiple variables, but you don't use all of them. In this case, so you need to declare which variables to use. In this case, I'm using all of them. So I select all, click add. These are the variables I'm using. I'll click next. The bottom here, if you wanted to use a subsample, but that's not possible with summary data, only with raw data. The type of analysis I want, it's neither mean structure or basic. It's full regression. So the estimator is ML, maximum likelihood. You don't need to change the convergence criterion. For options, at this point, I will just select standardized coefficients, and that is very helpful because you usually want to report standardized coefficients. Click next. And here I don't need anything. Click on finish. So Mplus gives you a reminder that it doesn't actually write the model for you. This is just a setup file. In the setup file, you have 5 Mplus commands: title, data, variable, analysis, and output. And with each command, we have options. The command that's missing here that we're going to add is the model command. But first, I'll walk through this title. This is the title of the analysis. The data command has here 4 options. The first is the full path for the data file. When you save the data file in the same place you save the code, you don't need the full path. So I'll simplify here to just the name of the data set. And I'll make sure I save this code in the same place I have the data file. I find that this is usually minimizes trouble, a shorter path. The type of data is correlation, means, and standard deviations. That's what I had in that matrix. Only one group. The number of observations is 34,810. These are my options for the data command. The variable command says these are my variable names in the same order as in the matrix, and I'm using all of them. Use the variables as the variables you're using. For analysis, type equals general. Type is general covers most structural equation models. Now I have to point out that these are all defaults in Mplus. So if I deleted this, the analysis would still run because these are defaults. I could even delete the analysis command. I could delete all of this and it would still run. In the output command, I just mentioned I want standardized coefficients. Now I'll add the model command. So each command ends in a column. Now, Mplus is not case sensitive. So we are using uppercase here for organization, but I could write all of these in lowercase. And my model, remember the intent to quit is my outcome, and all the other 5 are predictors. I will write intent, and then my keyword here is on. Doesn't need to be capitalized. Capitalized just to show you. So on here means regressed on. So this model means intent regressed on all of this, and you have to add with a semicolon. So this is an equation. This is the regression model. Intent equals to B0 plus B1 job plus B2 admin plus B3 experience plus B4 student plus B5 salary plus error. But Mplus doesn't use equations. It relies on keywords like on, which means regressed on. So this is the basic model. I don't need to declare more than this. There are plus we will also estimate the residual variance of intent, but it's estimated by default, so I don't need to declare it. I'll save, click on run, and ran. Here it repeats the code you used. It summarizes the analysis, number of groups, observations, one dependent variable, 5 independent variables, and it shows what your observed independent variables are. This is the summary of the estimation, and it shows fit information, which we are not going to talk about this now. And then model results. Now, the message you want to see is both fit information. The model estimation terminated normally, meaning that there were no errors. These are the model results. Here you have the coefficient estimates. These are not standardized, so they depend on the scale of measurement of the variables. Standard errors, this estimate divided by the standard error, which is a z-score, and it should tail p-value for that z-score. So these are all less than 0.05, so these are all statistically significant at alpha equals 0.05. I have an intercept here, which is the predicted intent to quit if all the predictors are 0, and I have the residual variance. Now, most papers will report standardized model results, which are in terms of standard deviation, so they don't have the scale of measurement. These are more interpretable if the scale of measurement is arbitrary. So we have here, for example, intent on job, the beta weight, which is the coefficient of job, is 0.229. This means that an increase in one standard deviation in job satisfaction is expected to correspond to a 0.229 change in intent. So back to their model here. Job satisfaction affects teaching intent to stay in teaching. So the results show that the more job satisfaction, the more likely you are to stay in teaching. Back to Mplus. Then we have a mean 0.032, and all the others, they are always statistically significant. It's important. So we want to use STD-Y-X standardization, which means it's standardized with respect to both Y and X. Here, STD-Y is standardized with respect to just Y. That is helpful if your predictor is binary, such as gender, because you don't want to standardize with respect to the standard deviation of gender. In that case, if you had gender as a predictor, you would use STD-Y standardization. And then it's important to note the R-squared. So even though all the predictors were statistically significant, they only account for 8.3%. So this R-squared of 0.083 means they account for 8.3% of the variance. So this is how you run regression analysis with Mplus.